Welcome back. In this applet, we have two similar triangles. The one on the left-hand side that I'm highlighting here with the mouse has a hypotenuse of 1, and then the one on the right-hand side is variable in size as well as shape. As you can see, I'm using the control points on these two vertices to change things. The height of the triangle and the base of the triangle, of the right angle triangle. Okay, so two similar triangles, and one of the theorems on the course is that for similar triangles, the corresponding side ratios remain invariant or remain the same. For example, the variation of the opposite to 35.5 to the hypotenuse is the same in both. So you get, when you do the calculation here, you get 0.581. Of course, here the opposite divided by 1 gives you 0.581. So what's interesting about the triangle on the left is that instead of having to do a ratio, the length of the opposite is already the sine. And that helps us comprehend what sine is from a geometrical point of view. The sine of an angle in a unit circle, in this first quadrant here, equals the height of the triangle. Now let's similarly interpret cosine. Now here, the cosine, of course, is the adjacent divided by the hypotenuse. So now you see that the physical meaning on the left-hand triangle, the physical meaning or the interpretation of the adjacent in this normalized triangle, we say normalized when it's reduced to a very specific size with hypotenuse 1, for instance, is that this length is the cosine. So the cos of 56.3, the cosine of 56.3 is 0.555. So we have interpretation for sine being the opposite when you make the hypotenuse 1. Interpretation for cosine relative to an acute angle in a right angle triangle is the adjacent length. And now let's look at tangent. So tangent here will be 7 over 4, 1.75. And I'll just change the actual scaling around here so that I bring things onto the screen. But so what that means is instead of normalizing to the hypotenuse of 1, we're making the adjacent, which you remember is the denominator, opposite over adjacent. It's the denominator in our calculation. We want that to be 1, so it's very smart. So what it means is if you want to compare sine and tangent, they're both increasing functions. They both increase with angle. But the tangent increases without limit. It just goes crazy when you get up towards 90 degrees. And the reason for that is you're beginning to divide by less and less and less relatively. Okay, but the important thing is that where's the line, where's the physical interpretation of this line segment is instead of being inside of the circle, it's outside the circle, starting on the unit circle. Starting here always and shooting upwards. So you can imagine as this goes up higher and higher, this becomes longer. So it gives us an understanding of why tangent can get massive, head towards infinity. And in right angle triangle trigonometry, it can head to infinity. And indeed, in general trigonometry that you do in Leaving Cert, it can become negative infinity. It can start with a very large negative number, and so on. But here we're only sticking to junior cert type of trigonometry. Thank you. Goodbye. See you in the next one.